Hello, welcome back to Tech Quiz House. Today we're solving LeetCode 15 3-sum. This problem is one of the most famous coding interview questions, and it tests your understanding of arrays, sorting, two pointers, and problem solving intuition. By the end of this video, you will not just know the code, you will understand the thinking process behind the solution and how to recognize this pattern in other problems also. So let's get started. So, what makes threesome so tricky? At first glance, the problem looks simple. Find three numbers that add up to zero, but the challenge is not just finding one answer. We need to find all unique triplets, and we cannot return duplicates. Monica did get a stack because their first thought is like, let's just try every possible combination of three numbers, and the idea is correct. But the problem is the number of combination grows very quickly. So the real interview skill here is learning. How can we reduce unnecessary searching? The problem asks given an integer array nums, return all unique triplets. So there are nums of I, nums of j, and nums of k, which their sum is becomes 0, and where I, j, and k are different indices, and the solution cannot contain duplicate triplets. So let's see, for example, this array we have nums for these numbers, and we have two triplets that are like -1, -1, 2, and -1, 0, 1 are two possible triplets. Notice -1, 0, 1 is the same as 0, -1, and 1. But we only return it once, so for that matter we return it the one of them. The first thought that comes to your mind is using through three nested loops. Like we can use three loops, like pick the first number within for I, pick the second number using for j, and the third number for the k. Check if their sum is 0. But it works sometimes. This works, but the problem is for the complexity analysis. It becomes of n cube for large inputs. This is too slow, and so we need a smarter and better way. Here is the key inside the optimal solution. Sort the array and using two pointers. So sorting makes searching easier. Why? Because sorting gives us order. So example, let's see this one. So the first example, so this is the nums or the array that have numbers. Just like after sorting, it becomes just like this. So after sorting, it becomes like just like this one, and after this one, we do like two pointers at a time. So now we can use the two pointer technique. So first, we need to have one fixed number, which means fixed one number. So fixed one number, and the other two pointers using two numbers to find the two numbers. So imagine we choose nums of I. Now we need to find the opposite by adding the left and the right pointers numbers, which means the left and the right, when we add up, which means left plus right, it must equal to the minus of the fixed number. So it we place and the left for this matter. So we place the left pointer is equals to I plus 1, which means the fixed number, we can say I. For the next number becomes the left and the right part starting from the end of the array. So after this if the sum is too small, we have three conditions. If the sum is too small, move left pointer to the forward, which means to the right one. And if the sum is too small, if sum is too small, too large, I'm sorry, if the sum is too large, move the right, which means move right to the left. So move right pointer to the left, so need a smaller sum. So after this, if the sum is 0, we can find the solution, which means one triplet, so we store it to our result. So what the pointers, how and find the answer. So you can see this visualization and you can check it out on this. Now we understand the intuition. Let's implement it step by step. The first thing we need to do is sort the array, so nums dot sort with the sort this function. After this, sorting what makes the two pointer technique possible. So, and once the numbers are in order, we can decide which pointer to move based on whether our current sum is too small or too large. So, next we create an empty list for storing. So, storing the triplet. So, I said result. And after now, we loop through the array. Each number will act as the first element of potential replace. So for I and range of so line of nums. So after this, we need before doing any work, we need to check something. That we check if we have already processed the same number. So if I greater than 0 and nums of I is equals to nums of I minus 1. So indexing starting from 0. And if this happen, we continue. This is important because the problem asks for unique triplets. So skipping duplicate starting values prevent us from generating the same answer more than once. So we say continue. After this, we can initialize the two pointers, which mean the left pointer starts from the I, which means the fixed 1 plus 1, and the right pointer becomes the end of the array, which means line of nums minus 1. And after this one, we can do it like we can calculate the sum of the three numbers. So uh, before we can calculate the three numbers, we need to have like as long as left before right, we keep searching, which means while left laser the right one, we can calculate the total. So total becomes nums of I plus nums of left, and after this nums of right. Yep, yep. After this one, we need to check the three condition. If the sum is exactly 0, we found a valid triplet. So if total becomes 0, we found our triplet, which means result. We need to store it. That triplet result dot append the three numbers, which means in the array. So nums of I, comma, comma, nums of left, and comma, nums of right. Yep. After this one, we need to, after stepping, we move both pointers inward, which means the left becomes to the right and the right goes to the left side. So the left plus is equals to 1 and the right becomes minus is equals to 1. After this one, but there's one more thing we need to do. So we need to check also the duplicate values on the left side. So we need to skip the duplicate. So while, this time also while, so left and the right, and nums of left, as we did before, is equals to nums of what? Left minus 1. Yep. And this time we need to move the left pointer to the right. So left plus 1 plus is equals to plus is equals to 1. And after this injury, we don't add the same triplet multiple times. So now if the current sum is less than 0, it means we need a larger value. Since array is sorted, we simply move the left pointer to the right. So if total less than 0, we need to move the left pointer. So is equals to 1. And another condition is become the total greater than 0. We need to move the right pointer to backward. So that's it. If anything I missed, nothing. So finally, After this one, the set once the loop finishes, we found all unique triplets. Finally, we return the result. So the result. So that's set. So let's check it. It's accepted. Let's submit it. It's accepted. One thing we left is a time complexity analysis. So sorting it takes like n login and the two pointer search takes off n square. So it becomes the overall time complexity becomes of n square, and the space complexity become the ignoring the output array we have of one because we only use pointers and variables. So notice ignoring the output array, the space complexity become of one. And we have the big lesson for threesome is not the code is the pattern. Why, when you need to find the pairs of triplets in an array, think about sorting plus two pointers. This technique appears in many problems like two sum and the foursome and the container with most water and pair problems with target. This is some problems that might be the same pattern have in the LeetCode. And during interviews, don't jump straight to the coding. Find first ask yourself like, can I sort? It's helped me like remove unnecessary searching. Of it reduces the time complexity becomes of n cube to the decrease to of n square, and that's it. You need to have this mindset for solving this one. So if you found this explanation helpful, don't forget to like, subscribe, and share with your friends. This take with us. Keep practicing, keep improving. I'll see you in the next video. Thanks for watching.